Welcome friends. Now we will see next questions and those will be on logic, propositional logic and predicate logic. So let us start. Which of the following is not a statement? Canada is a country, of course, it's a statement. Right statement, true statement. Moscow is the capital of Spain. Is it a statement? Yes, it's a statement, though it's a false statement. Not true statement, but still it's a statement. Now see the third one. This statement is true. Is it a statement? No, because we don't know which statement he is talking about. Only this statement is true. Since we don't know, we can't establish whether this statement is true or not. In propositional logic, any propositional logic statement, we must be able to ascertain whether it's a true or not. Toronto is an old city, of course it's a statement. So this statement is true is not a statement. Answer is C. Statements which are questions, commands or opinions are not propositions. A proposition is a statement which is answered either yes or no. If it has more than those answers, then whether go to predicate statements, predicate logic. Propositional logic means only yes or no, true or false. That's it. Only two answers. Binary statements are there. So statements which are questions, commands, those are not. Like where is Rohini? There may be many answers. Bombay, Delhi, Calcutta. So it's not the statement. How are you? Good, bad, rich, poor, anything. What is your name? Name can be anything. So these are not true, false type of statements. They are not propositions. A proposition statement or assertion is a sentence which is either always true or always false. That's about propositional logic. Propositional logic means true or false, yes or no. Answer is coming only like this, straight answer, then it's propositional logic. Otherwise it's not propositional logic. A statement is not a proposition if we cannot decide whether it's true or false. As we saw previously, this statement is true, we can't decide whether it's true or false, so that's not a statement, propositional statement. If truth values of statement P is true and Q is false, then the truth value of P and Q, this is symbol of AND. There are two things, AND OR. P and Q means it will be true only if P and Q both will be true. Conjunction of P and Q. So since P is true and Q is false, since Q is false, so it can be true only if P and Q both are true, so this will be false. B is the answer. Answer is B. So you see, propositional statements are either true or false, but they can't be both at the same time. They can be true today and false tomorrow, but if they are both true and false at the same time, then again they are not propositional statements. Propositional statements are either true or false, can't be both at the same time. At different times they can change their stand. So when we are talking about propositional logic, we shall be aware of these symbols. AND symbol, conjunction, A and B, OR symbol, disjunction, A or B, implies means one means other thing, implication A and B, conditional implicate, that is biconditional, this symbol means if or only if. One statement is true only and if and only if other one is also true. A implies B. A is true if and only if B is also true. And negation. Negation has two symbols like this also and wave also. So not negation. Now consider, this is an important question because many of propositional logic problems have this. Whenever you talk of propositional logic in exams, a lot of questions come like this. So it's important. Mark is rich, that is statement P, and Mark is happy, statement Q. Then the symbolic form of the statement Mark is poor but happy is. No, P is Mark is rich, so Mark is poor means it's negation, opposite. We have to take this, negation P. And Mark is happy, poor but happy, happy is there, so Q will be taken as it is. And now here, Mark is poor but happy is written, means Mark is poor and happy. Mark is poor and happy. It's not that Mark is poor or happy, no. Mark is poor but happy means Mark is poor but and happy. Okay. So we will have and symbol here. So negation of P and Q, that's the answer. C is the answer. Negation of P and Q. We will come next. Given the truth values of P and Q as truth P and those of R and S as false. Now the truth value of negation of P and Q or negation of R and S is. This is a bit tricky question. Here one thing we have to consider, that there's no bracket. So we have to decide whether we have to calculate negation of P and Q first and then negation of R and S first and then use this R symbol, or we have to take negation of P and Q first, then it's R with negation of R, and then we will take resulting thing which and then solve like this. So we have to follow the precedence rules. We have to take care of the precedence rules. Let us see what are they. Answer is of course B, F, it's false. How it is, you see. Precedence rules say first precedence is parenthesis. If parenthesis is there, under that it will be calculated first. Then second precedence is negation. We have to consider negation. Third precedence is conjunction, and this is important. And fourth precedence is disjunction or. So first we have to consider and then only or will be considered. First we will consider and then or. Take care of it. And then fifth is implication and then biconditional. Now you see here, this is parenthesis, first it will be calculated, negation of P and Q. Means if anyone is false, then it's false. So this is true, but this is false, this is false. Now here, this will be considered later, that or. First we have to consider this, that is and. So negation of R is true because R was false there. So negation of R is true and S is false. So since one is false and operator is there, this entire thing will be false. And false or false means it is false. So that's how it has to be. We can't operate this or before we do both, because and has a higher precedence than or here in this chart. So that's why it's coming out to be false. I think you have understood it. Let A and B two statements formulas, then which of the following is a tautology? Now what is a tautology? It's a new term which has come. Tautology. A and B is a tautology, or A implies B is a tautology, or A union B is a tautology, or A or B, or A or B under bracket, then or not B is a tautology. Which is a tautology? So let us see this question. Answer is of course D. Let us see what is a tautology. A tautology or tautologous proposition has a logical form that cannot possibly be false, no matter what truth values are assigned to the sentence letters. Means whatever values we assign, these will be true only. Something which is always true, whatever you assign values, that's called a tautology. Like this proposition, this will have the same values, whatever changes you do. So here you see A or B or not B. So A or B, anyone is true, it will be true. And then since this will be true, then this will also be true, entire thing will be true. That will not change. Unless, but if anyone is false, suppose B is false, then what will happen? And A is also false, then this will be false, but this will be true then. So this will always be true, that's why it's a tautology. While here, if A is false or B is false, then it's a false, it's not a tautology. Anyone can be values, but here whatever values you give, whether you give A positive or negative, or whether you give B positive or negative, this is going to be true only. Its result will be true only, that's why it's a tautology. There is contradiction also. Three types of statements are there: tautology, contradiction and contingency. In contradiction, what happens? Has a logical form that cannot possibly be true, no matter what truth values are assigned to the sentence. So if it's a tautology, whatever value you assign to the statement, to the parts of statements A or B, P or Q, it's always true. But if it's a contradiction, means whatever value assigned to these variables A or B, it will always be negative, wrong. And contingency means has a logical form that can be either true or false depending on what truth values. So अब ये most of the normal statements वो contingency statements ही होते हैं. They will be contingency statements because whatever values you are giving, on that basis it will change. But whatever value अगर आप देते हो वो हमेशा positive ही रहता है, then it's a tautology. अगर वो हमेशा negative false ही रहता है तो it's a contradiction. Otherwise contingency. So there are three types of statements in propositional logic, that is tautology, contradiction and contingency. Coming to next question. Now we will come to predicate logic. Translate the following statements into first order logic, that is FOL, first order logic, that is predicate logic. Predicate logic is also called first order logic. For every A, if A is a philosopher, then A is a scholar. For every person, if he is a philosopher, then he is a scholar too. So this symbol, very well we all know, this is universal qualifier, universal quantifier. For every A, philosopher, A, scholar A. So this seems to be true for every A. This is, if A is a philosopher, then A is a scholar. A must be correct. Now here, there exists, is existential quantifier, there exists some A, some philosopher who is a scholar also. So that's not the meaning of this statement. Like there is some person who is a philosopher also and a scholar also. No, here it says for every person who is a philosopher is also a scholar. All of them mentioned, and now that is irrelevant. So A is the answer. For every A, if he is a philosopher, he is also a scholar. So basic elements of first order logic or predicate logic you must see. Universal quantifier, this symbol, ulta A. Existential quantifier, this symbol, ulta E, for some at least one. So universal quantifier is for all, everyone, everything, and existential quantifier is for some at least one. And then there are constants, variables, predicates, function, like brother, father, these are predicates, some properties. Then function, square root, these things, connectives like this are there. Then equality, quantifiers, universal quantifier and existential quantifier. So these are elements. On this basis you can understand the entire predicate logic. Now coming to the next question. The adjective first order distinguishes first order logic from which? In which there are predicates having predicates or functions as arguments, or in which one or both of predicate quantifiers or function quantifiers are permitted. So of course this question is about higher order logic. First order logic means predicates will not have predicates. Predicate will only have its property, that's all. But here predicates are going to have predicates and functions are going to be arguments, like that. So means that will become higher order logic. So that is higher order logic. Now next question is, which can be converted to inferred equivalent CNF sentence? Every sentence of propositional logic, every sentence of inference, every sentence of first order logic, all of them mentioned. Now what is CNF? The question is this. Of course answer is C. CNF is connected with first order logic. So every sentence of first order logic can be converted to CNF. That's a very important part of it. What is CNF? It's conjunctive normal form. CNF, conjunctive normal form. A sentence represented as a conjunction of clauses is said to be conjunctive normal form. The conjunctive normal form states that a formula is in CNF if it's a conjunction of one or more than one clause, where each clause is a disjunction of literals. In other words, it's a product of sums where. So basically what we are doing, we are simplifying the predicate logic statement. That first order logic statement we are simplifying and putting it into conjunctive normal form, that is CNF, so that further operations can be easy. So steps to convert a formula into CNF. How are we going to convert? We eliminate all the occurrences of XOR, conditional, biconditional from the formula. We convert it into its equivalent formula containing only these. OR operation, AND operation, NOT operation, only this we convert it. We use the following logical equivalences. You can see A XOR B is A union B and not A and B. Like that, we can, using these logical equivalences, we will eliminate XOR operators, conditional operators, biconditional operators. Then we move all the negations inwards to appear only as part of the literal. The not symbol can only precede a propositional variable or a predicate symbol. To accomplish this, we use the following logical equivalences. Like double negation is there, then it's a positive thing. De Morgan's law we use. So using this, we can convert any predicate formula in predicate logic to a CNF and operate further. Now next question is, which is used to demonstrate on a purely syntactic basis that one formula is a logical consequence of another formula. One formula is a logical consequence of another formula. So we are going to use deductive systems. Answer is A, deductive. Now we are see how many types of 6 types of reasoning are there in AI. Deductive reasoning is deciding new information from logically related known information. It is the form of valid reasoning, which means the argument's conclusion must be true when the premises are true. And like you see, all the humans eat veggies Suresh is human, so Suresh eats veggies. So on the basis of two statements, we are deriving the third statement, then this is deductive reasoning. On the basis of two statements, we are getting a new knowledge, that is deductive reasoning. Okay. Then there is inductive reasoning. We have got only one premise, only one thing we have observed, and on that basis we are generalizing to other things, that's inductive reasoning. Arriving at a conclusion using limited sets of facts by the process of generalization, like all of the pigeons we have seen in the zoo are white. जू में गए सारे पिगन्स वाइट दिखे, देन हमने कंक्लूड कर दिया देयरफॉर वी कैन एक्सपेक्ट ऑल द पिगन्स टू बी वाइट. हमने जनरलाइज कर दिया कि नहीं जी कोई ब्लैक पिगन नहीं होता, सब वाइट होते हैं. सो इंडक्टिव रीजनिंग कैन बी wrong also sometimes, but this is how it is. On the basis of one observation we have generalized it to everything. There is abductive reasoning also, which starts with single or multiple observations, then seeks to find the most likely explanation or conclusion. Like cricket ground is wet if it's raining, then axiom is cricket ground is wet means it is raining. Cricket ground gets wet when it rains. Now cricket ground is found wet, now it shall be raining. Though it may not be true, someone has put water on it. It may not be rain, but that's how with abductive reasoning we can reach those conclusions. There's then common sense reasoning, which is very common sense, like one person can be at one place at a time. This is common sense reasoning. In monotonic reasoning, once the conclusion is taken, then it will remain the same even if we add some other information to existing information. Like monotonic reasoning means always true. Whatever changes we do, earth revolves around the sun, always true. Whatever changes you do, nothing happens, it's true. So earth revolves around the sun is a monotonic statement, it's a monotonic reasoning. Then there are non-monotonic reasoning, most common sense reasoning, like some information we will provide and that will change the thing. Like suppose birds can fly, there's one statement, and there's another statement, penguins can fly. So birds can fly, and we have another information also that penguins cannot fly. Okay. Then we have got another bird, pitty. Pitty is a bird. Now whether pitty can fly or not. So on the basis of general reasoning, birds can fly, we will say pitty is fly. Pitty can fly. But if an information comes that pitty is actually a penguin, it's not a normal bird, it's a penguin, then we will say pitty can't fly. So on the basis of, it's not always true, some information we get and this changes, then it's a non-monotonic reasoning. But earth revolves around the sun, whatever information you are getting, this will be true. So this is a monotonic reasoning. Now coming to the next question, this is also very important question. Suppose the predicate f, x, y, t is used to represent the statement person x can fool person y at a time t. Person x can, f is for fool, person x can fool person y at a time t, f, x, y, t. Then which of the following statement represents the meaning of formula? This is a formula given. Now we have to find which is the statement represents that formula. Now we read, what is this? For each x, this is universal quantifier. For each x, there exists existential quantifier, ulta e, there exists a y at a time t. There exists a time when cannot fool, this is opposite of fool, cannot fool x, x cannot fool y at a time t. Okay. Means everyone can fool some person at some time. No, that's not the meaning. No one can fool everyone all the time. Yes. there exists a person X such that he can't be fooled at some time t. That is coming to be means no one can fool everyone all the time. Everyone cannot fool some person all the time, that is not the meaning. There exists some person X, no, for every person X, there exists some Y who can't be fooled, so that X can't fool Y at some time. So so no one can fool everyone all the time. Nobody can fool some person at some time. So this is the logical thing. B is the answer. And if you want to derive, this has been derived from De Morgan's law also. For each X, there exists a Y at a time t such that A can't be fooled, X can't fool Y at that time t. So this we can apply De Morgan's law, that negation of there exists X for each Y, for each t, fxyt. Means fxyt has been defined at some time. We say there does not exist a person who can fool everyone all the time. That's how this is. There does not exist a person who can fool everyone all the time. Thank you.